the current design is for this is the current design that I've been working on for the past couple weeks. Basically, ever since Champs, I've kind of just been slowly trying to CAD and trying to add detail. This is heavily inspired by the robot I posted in Slack, which is the Prepatech robot. They had the same sort of double end effector that pivots completely passively. And I picked it because I thought it was a pretty simple design. Because we outlined that what I wanted for this robot was to practice building a better lift, just because we've never really built a good lift that can really be competitive. Looking at this past year's lift, we had a continuous rope lift, which no one really uses anymore, and we kind of paid the price for it. We had a lot of issues with like tensioning, and as soon as we got it working, then we could only go so fast with our speed and with how consistent we can be. And it's just overall really finicky, and probably we're gonna not do a rope continuous lift again. The other continuous option would be a belt lift, which just adds complication, and it's just generally something we probably wouldn't do. So the next option was a ThriftyBot cascading lift, and we compared this one and the gray T one, but this one overall just seemed a lot more robust compared to the gray T from WCP. The gray T has a giant gearbox that's in the center of the lift, and the chain and sprocket is in the center. But the ThriftyBot lift puts two motors opposite each other, driving the same shaft. And we just thought that would be better for stability and speed. So I'm just going to go through the lift here. So I guess we should start with the main. So that's one of our main goals, was to make a fast cascading lift, because I feel like we're going to probably need it in the future, and it would be good to know how to make one. And then we also wanted to practice climbing, because I feel like, especially this year, that's what kind of stopped us from being any more competitive than we were. Because we could score coral, we could do algae, and all we had to do was figure out how to climb, and we couldn't do that. A lot of it was also due to the fact that we didn't initially expect to actually attempt to climb. So it wasn't accounted for in the CAD. There were CG issues that were completely off, and it just wasn't really great. So we'll get to the climber and this whole situation in the front. I'm going to go to the lift first. All right, I guess the end effector first. So this end effector is a dual. So this has two 550s that are staged, and pulleys that would roll the wheels in opposite directions. The front two wheels would help do algae, and then the back two wheels would do coral. The churros are going to act as structural pieces to keep the right width, and also a hard stop for the coral. If we do make something like this, we will probably add some sort of a beam break or something to detect whether we have coral. But then again, we don't know how far we're going to get with this, so that's not fully thought out yet. I also did make, when I first put this whole assembly together with the game elements, I did realize that trying to intake coral, it may be nice to have a cutout here so that we don't have giant issues intaking. Maybe we don't. I mean, none of this is really tested. The team that we're copying, they don't have a release CAD, and I kind of just took the concept to create my own geometry around that. And so this end effector is very drafty in terms of its current dimensions. The wheels and stuff, it's probably going to stay the same. Yeah. So this lift, my initial idea was to create a really sturdy lift by basically putting the lift on a 2x2 that ran across the whole side of the drivetrain. But if we were to copy the ThriftyBot lift, I soon realized that we couldn't really do that just because of the way the lift works. and the way the motors had to be packaged. So instead, I kind of just straight up copied the ThriftyBot design. The biggest difference is we're using Rev hardware because a lot of the bearing blocks, all the bearing blocks that we have are Rev. So that's the biggest difference. But the actual the way that the lift works is the same as a ThriftyBot. It's a cascading with a first stage chain. I have a couple pulleys set up, and then the constant force spring to pull the carriage up. The carriage is also the lift is also unique in a way that our middle stage is open, because that's the only way that with this design. And I saw this with the Prepatech robot, was they had a open middle stage similar to something like this, so that they can reach the L4, with the coral. Yeah, but a lot of it's going to work exactly like a thrifty lift. The carriage is also a bit wonky. Again, they did the exact same thing. The carriage is basically, the end effector is basically offset by the carriage, with the bearing blocks not on the ends of the carriage. And yeah, so we'd have two Neos. The reduction right now, I put like a, what is this? So I put 2 3-to-1s. We'll probably change it, but that part I'm not nearly as concerned about compared to the rest of the robot. In terms of bracing, to make it sturdy, we will probably just make custom gussets similar to this here. Either that go, I had idea to combine a gusset between this box part and here, or we may just have a gusset that goes here to here and try to make that work. But yeah, I mean, that's the lift. It's pretty similar. It has all the components of a ThriftyBot lift, but packaged slightly differently. But it should work the same way. And then, like I said, we also wanted to try to make a climber that worked. And we thought a Spectrum's climber this year was really cool, because it looked really simple. It kind of just pivoted. Doesn't look like a giant amount of aligning. They kind of just drive into the cage and pick themselves up. So that's kind of what this is. Initially we had the idea of, let's make an algae ground intake, ensure that it works, and then try to build a Spectrum style climber that, in the case that the climber doesn't work, we can just swap it out for the algae intake and then just have an algae intake. But if the climb does work, we climb. Eventually I played around with it and found that there's kind of a nice geometry that allows us to do both. Yeah, I found this nice geometry where we can climb on the cage with this shaft, but still be able to intake algae using these rollers. Right now I have a pretty big reduction on this. So that's the downside with this, is obviously there's a lot of load, just because the whole robot is going to be climbing on this shaft. So I have this is close to like a 70 or a 80, I think, with a 2-to-1 and a 2-to-1 and a 2-to-1. So it's a really huge reduction, which means the pivot will move slower than we want it to. But if we want to climb, I think we need the extra power to do so. Yeah, and then we will also need like a climber foot, the same way Spectrum has. I don't think it needs to be on our bumpers. We can probably figure out a way to mount it going across here. Haven't thought that far through it yet. Yeah, and I put 4-inch wheels because based on availability, we have a lot of 4-inch wheels at Westside. So if I open the master sketch here, so yeah, oh, that's the wrong one. This geometry allows us to, this was at the, so this is what we would look like climbing. So we would basically anchor the cage down here, and then by moving the pivot up, the shaft here would just kind of slam on the cage, and this would be the position that we climb in. But it also allows us to get really low. The intake is able to go down basically all the way down to the ground, so that driving into the cage to try to get it in the robot is easier. But this geometry also allows us to intake the algae. Scroll this down. Yeah. So this is the algae ball, and as you can see, it'll allow us to intake the algae. Here, let me stop this. Yeah. So going back to the full assembly, you'll notice I made a. Oh, also on the algae intake, I initially had a plan for the rollers to do similar to what we did this past year, but that got really complicated packaging-wise to do like the 2 gears that ran on sort of a dead axle. So instead, we just put the motor closer to this end so it's not completely vulnerable. We put the motor closer to the robot side, and yeah, it was just a lot simpler to do. It was just overall a lot simpler to do. Yeah, that's about it. A couple of details. We're gonna probably add tensioning for the end effector to tension it angled sort of upwards. We're gonna tension it so that it doesn't fully flop down, and we're gonna make hard stops for it. But yeah, that's gonna be a bit further down the road once we feel more okay with this design. The electronics are also very preliminary. I realize this really doesn't work, so I'm gonna do something else with electronics. Yeah, that's how far I've gone so far.
Why don't you put the battery in the front?
The what?
The battery in the front.
It was mostly for CG, because a big thing that we realized this year, especially climbing with the cage, was that it was really important that in order to have a successful climb, the anchor of the chain has to be above the CG of your robot, which we learned through a series of Andy Mark videos and just testing in real life. We found that the climber only worked when the CG and overlapped directly with the chain of the cage. And so putting the battery on this side shifts it towards the algae intake, which is kind of what we want, because if we put 14 pounds on this side, this would move. The CG is this black and white dot, by the way. If we put the battery over here, the CG would move too far to the back of the robot, which would make it extremely difficult for us to climb without like adding a bunch of weights over here. Yeah, that was the main reason why. I mean, we also considered just putting the battery flat. We obviously didn't like that idea just because flat batteries usually are a giant pain. But if it came down to it, we could do something like that. It's also just tough because climbing like this, it's pretty important that the robot is symmetrical so that the CG doesn't shift to the left or the right as well. So I tried my hardest to design everything so that the CG stayed really close to the center line of the robot going forward and backwards. Yeah.
So the L2 score, is that possible with this design?
I think it would be possible. It just will be a bit. It's kind of like how we would score L2, to where it's not convenient, but you can try and it would work. So yeah, we would just pivot it down. Let's see if I can unfix this. We kind of just put it down, L4, L3, and L2 would be somewhere here. Oh, overshot. It would be somewhere here. And then our intaking would be all the way down. The lift, like most of the robots this year, it's also basically at full height. We can't go any higher, which is why I made the open top thing.
I see. So there's a very small distance between intaking, moving up a little bit, L2. It's pretty minimal. That's nice.
Yeah.
And there's no motor that pivots this? It's all just passive?
No. Yeah. The way they didn't even have any sort of tensioning. They kind of just had an axle. It looked like they kind of just had an axle that just hard stopped it at like the lowest position it can be. That just yeah. But I would like to have something that tensions it so it's it reduces when it comes down. It reduces the force on this box. And also just to reduce damage and make it easier on ourselves. I mean, my original idea was to make it active, but I realized all the complications that had to do with that, so I kind of turned away from that really fast. Yeah.
My vote is to go away from algae. I don't think it's worth very much, and climbing is more important. But if it happens to do algae, I guess that's okay. But I wouldn't sacrifice any of your climb design for the algae.
Okay. Yeah, because we realized that as soon as they updated the rules for TRI and we saw that there's no more co-op, we realized that doing processor really isn't that important. And the only reason that we could have a ground algae intake is if our lift breaks, which this year it happened quite a lot. But I think with this design, the failures that we had this year, like string coming off of pulleys, not zeroed, the lift not being completely zeroed, and there's a lot of really stupid stuff that it just came down to us not doing great checklist items. This lift shouldn't nearly have as many issues. So, yeah, the algae we can probably just remove without changing the design too much. Should make it easier for us, if anything.
I wouldn't call that yet because like our this design, the DiscoBot design still has string throughout the lift, right?
Yeah.
The failure points are still there. The only difference is we have more experience now at bowling it. We'll still probably have issues with it, but from my perspective, it's like the issues are okay because we're gonna have to learn them if we're ever gonna build another elevator. And the whole point of this robot was to essentially build a lift and make it as fast as we can possibly make it reasonably.
Yeah, I think it's a lot of good work. I mean, I like how simple it is. Looks like it's pretty quick to build. I'm not convinced that a cascade elevator is that much more effective than what we had. I'd have to read and do some searching, but I thought our lift with maybe a second motor and a slightly different gearing could go much faster. Obviously, it doesn't go down as well, but I think you could. I don't know in this design you even need to go down very hard because you're not.
Yeah, you really don't.
Force, so.
From what I've looked at, like a lot of teams do continuous elevators like we do, but the difference is essentially all the kits that like are sold are set up for cascading elevators. So like if you look at any of the Rev stuff, the ThriftyBot, Gray Tea, everything is for like a cascading elevator, and the main like difference, the main like performance difference from cascading and continuous is the cascading. Every time you go up a stage, it moves that one factor faster. So going from like our first stage, our second stage, so our carriage will go double the speed of the first stage because of the way it's like set up. But and then you've got a third stage, it'll go triple the speed, right? So that's just the main difference. A continuous elevator, only one stage moves at a time, and so that's like the main performance difference. Would it matter to like us? Probably not. But at the end of the day, it's just more experience for us, I think, the way I look at it.
But like you say, the top teams are using continuous, and they've figured out how to make them go fast. And the kits don't even sell these sort of things because their continuous can get too complicated, right? So
yeah,
I don't know how much we're going to learn from a cascade versus continuous. I think we make our continuous fast and better, and then maybe that's just the lift we go with in the future. That's kind of my just quick thought process, but I need to think more about it probably.
Yeah, that's true. We could also do that, and we just have to. I mean, it's just spending more time to make it better, right? I think the lift this year I didn't work on it like fully, right? But the small time I have like spent with it, what it seemed like was it was almost, some parts of it were overbuilt and some parts of it was like kind of underbuilt in a way. So like some parts of it failed too quickly for the other parts of it. It's like limiting the other half of the system basically, because from what I've seen in general on Chief Delphi is like elevators don't actually need that much like gearing. Some of like a lot of the elevators only recommend like 6-to-1, and then that's it. But I think our elevator is pretty significant gearing. So it's just down to optimizing it, right? Is essentially it. It's just more. We just need more practice.
Yeah, no, I think it's interesting. Okay, yeah, we'll wrap up just this recording, and then maybe we'll talk a little bit more afterwards here.